Hello, everyone, and welcome to today's SANS webcast, Shift Left, Integrate Security in Your DevOps Lifecycle, sponsored by Cisco Systems. My name is Carol Auth of SANS, and I will be moderating today's webcast. Today's featured speaker is Remi Philippe, Principal Engineer at Cisco's SBG. If during the webcast you have any questions for our presenter, please enter them into the questions window located on the GoToWebinar interface at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to Remi.
Awesome. Thank you, Carol. Hi, everyone. My name is Remi Philippe. I'm a principal engineer with Cisco. I've been working in the area of policy and network security and also just security as a whole for a few years now. And the goal of today is to give you an intro, because 1 hour wouldn't be enough to go through the whole thing, but a good intro on how to implement policy and security as close as the developers as possible, but in a way that doesn't kind of create frictions between teams. So we're going to go through a few things today across this. The first thing, what's up with security in the CI/CD? It's probably like every single website you go to today actually put some things around CI/CD integration and stuff like that around that. We see that everywhere on that. So what's up with that? Why should you care about that in today's world? Why is policy a good candidate? Why should you start with policy? You're probably thinking maybe I should start with EDR or other solutions. Well, actually, policy is a good starting point, and we'll talk about why in that model and how you can actually implement that pretty simply across the environment. We'll show how policy fits into the CI/CD pipeline, and today we'll be using Jenkins to give this, but really any kind of pipeline will actually work in there. Then we'll talk quickly about why we need to do this at this point and why this policy is important, what you should look for when you're building this policy and integrating this policy. And we'll go through a few integration examples of what a policy could look like across your environment. So those are the kind of the key things that we'll be going through today. So let's get started. What's up with CI/CD security? There's a few things around that. Like we talk about shift left, and shift left is just like moving towards the left of the CI/CD environment. So think about your prod being as far right as possible, and basically your developer as left as possible. And the idea is to move as close as possible to the developer across the environment. There's a few reasons we actually don't do that today. And to be fair, security was always an afterthought in the developer world. And to give you a bit of context, I used to be a developer myself, and when I was developer, I can guarantee, and that was a long time back, but when I was developer, there was never a metric on code security. You would have metrics on bugs, you would have metrics on time to deploy, performance, but you would never have a metric on security. So the developer builds something, and he pushes it with whatever metric is actually important for him. If I give you a metric that you have to reach a super high performance, all your focus will be on that, unnecessary security. So you're going to do that. And anyway, someone else is there for security, right? We pay whole security teams for that. So why should a developer care? So developer does his job, builds his code, goes through his development process, then gets to some network security team at some point to go and implement this code in production. Network security takes it. They secure something which they don't really know what it is that they're securing. They just get like usually a whole bunch of documents around what the application is, what it works, does it need public access, all that stuff around that. And you just go and implement that. Now, the problem I will say is that you have corporate security guidelines, and a guideline wouldn't be fun if it doesn't have an exception. So when network security actually goes and implement that, they have to get into the mind of the developer and also map that to the 500 million exceptions that they have in their environment to see, okay, where does that fit in? And to be fair, in developers always have a special project. So it's always they're very special and their thing has the highest priority and needs the best exceptions and needs the complete access and so on. So as network security, you actually need to go and dig and understanding what they want to do. When this is done, now you get to a next level. And now you need to go and have the security or CERT teams go and start looking into, okay, how do we instrument this thing? How do we actually get login? How are we able to reverse engineer an intrusion or something like that around those areas? And obviously, there's always an exception again, because, the agent is going to kill the performance of my machine. So, I don't want any of your agents, or I'm using this special cloud across the environment. And that's a lot the process we see today. And I'm not sure if that's the process you actually see in your own environments, but it's probably somewhere close to that. And again, things are changing. But at this point, we sort of have a problem, because we're actually there, and the person who knows the most actually doesn't really focus on security as per se, and everyone else has to basically reverse engineer their work. Now, developer actually does know the best about his application. He knows the relationship between the components. He knows which code path he's not tested well enough across the environment. And he knows as well which backdoors he put in during development. And when I say backdoor, I don't think backdoor in a bad sense. I'm just thinking backdoor in the sense, I'm trying to debug. I need to access this specific function without authentication, for example. So he knows those things that are there that he may or may not have missed while he's doing that. So why don't we actually integrate the developer in the process? And what we've seen by talking to other developers and other security teams is it's actually a developer productivity problem. Like, again, metrics don't necessarily align with what the developer has in mind and what he wants to do versus what the security wants to do. And he sees that as a bottleneck. The problem when I say bottleneck is you're forcing the developer to learn about a new tool, a new UI, or something else in the environment for him to integrate into the process. Or you're forcing him to get an Excel spreadsheet and to document stuff in spreadsheets in there. When that happens, it's always a question, let's go as fast as possible across the environment. Let's go quickly. We just get through this paperwork and get done with it. So first thing, developers don't like UIs, and that's a wide kind of well-known thing in there. There's exceptions, of course, but they don't really like UIs. So if you are talking about one, you could potentially get something out of it, but actually you're probably talking about multiple UIs. Like you're probably talking about 3 or 4 like different enforcement points, different EDR platforms and stuff like that he needs to learn. That's not going to work. So we need to bring the security down to the developer in a language he understands and in a format that he can handle. So he needs to be able to use VS Code if he wants to use VS Code, or Vim, or whatever he wants. And that should be what he uses to go and move forward with the environment. And that's pretty important at this point, because we actually do want the developer to be able to stay in his environment, because that's where his productivity is. His developers spend a huge amount of time setting up their IDE to get it really nice and neat in there. Now, when we have that, we also need to align with the development process. If we get developers to write a policy that goes inside his application, but then the CI/CD, all the dev tests and everything doesn't take care of it, well, it doesn't really serve a big purpose, right? So we actually want to have the whole chain be allowed and instrumented to handle this case. And then finally, why we like developers, while they're very trustworthy people, I mean, you should not necessarily trust anyone, or at least verify what's going on. And there's a few reasons for that. And errors happen. If someone just fat fingers and opens, for example, port 80 to internet, that may not be a good idea. If you don't have any guardrails and you automate the whole system, you're going to run into a problem. So those are things we actually want to take care of, and we want to spend time on to actually make the developer experience better across the environment. So why is policy a good candidate to actually get started? There's a few reasons for that. Policy actually solves a problem for developers when they get in. And that's kind of the reason for that is that when you go online and look at how to deploy an application, it always looks like that. It's internet accesses some kind of firewall, and then finally there's a server behind it. I mean, logic makes sense. In that case, why do you need to waste any time on that? So that would be a very valid kind of scenario for not wasting time. Now, I'm pretty sure none of you on this webcast have these kind of environments, and most likely, the environment looks at best like that, and I did have to condense it because it just wouldn't fit on a slide. So you probably have some DDoS prevention, you have an edge firewall, you have a DMZ firewall, you have an ADC controller, so F5, Citrix, or a load balancer, inspection device, something like that across the environment. If you're using Kubernetes, you have an ingress controller that's in front of there. And then finally, you have your applications behind that. And if you were to stop there, would be kind of manageable. But usually it doesn't stop there because your application actually has dependencies and it needs to access AWS through an ALB, and it has to access a set of security groups to go and reach a certain set of lambdas running there. And then it doesn't stop there because obviously someone will come in and tell you, hey, we need to scale out this application. So you have to go and handle that as well. So now your very simple policy problem, which was enforcing internet access to the application server, has a total of 8 policy points across the environment. So why do I say it actually makes sense to start there? Because we can actually take care of those policy points. We can actually generate a policy which is enforceable directly on the host, in the container environment, on the ADC device, at the ingress level, and even on firewalls and other equipment there. So one single policy that actually goes and sets across the whole environment. That's pretty neat at this point. Other thing, developers are somewhat aware about policies. And if you can make it a drop-in kind of thing, as an extra file they have to handle, and you don't ask them to instrument code or modify stuff inside their environment, well, it's actually something that they may accept. That's why policy is a great place to start when it comes to integration and to shift left across the environment. Hopefully, all this makes sense. So how do we get all this to actually fit across this policy environment? There's a few things around that. So we want a developer to be able to define his policy. So we start at the top left side and we define a policy in a JSON format here. A YAML format. Could be YAML, could be JSON, could be whatever you want really across that. The policy goes inside the source control, Git or whatever. It's most likely Git today across the environment in here. Once you've done that, the build pipeline runs. Think your Jenkins, think your drone, or any other thing that you're actually using for that. And when you go through the build pipeline, you're going to have a linter that runs. And this linter is actually connected to the policy platform. And in the example, I have our policy platform is situation across this environment. And we'll see a bit more about that, but that's around it. So the linter goes and talks to the situation and gets information on the policy that should be enforced, that are allowed, not allowed in there. And that comes down to the guardrails. If I have a linter and I know my policy is actually breaking the policy which is defined by the security team, I should fail the build now, rather than waiting for the whole deployment to then just at the end say, hey, it doesn't work. So that's the value of the linter. Once this linter runs, if you got a success in there, you go down to deploy the policy to dev. Then you run all your testing in this environment with your policy deployed across the environment. And that's an important one, and we'll talk about that again later, but understanding and seeing this and being able to have your policy during the testing cycle is actually very important, because lots of times an application may fail just because the policy in dev are not the same as the policy in prod. So if you carry over your policy across the pipeline, your testing becomes much more accurate across the environment. So we run that. If it fails, we just fail the build again, and we give an error to explain why we failed the build. And if we succeed, we can go to the next steps of the pipeline, which could be promotion or artifacts or things like that across the environment. So that's a pretty simple pipeline. Obviously, you can go much more complex across this environment there. Now, today's focus is really around deploying the policies to dev. So I won't spend too much time on linter. I'd really focus on that point for you to understand how to move forward in that area. So why do we want to do that? Policy lives with the software, and there's tremendous value to policy living with the software. The main value is rollback. Say you're running version 1.0 today. You go adding version 1.1, 1.2, 1.3. But at 1.3, you just figured out that actually an important feature got broken in 1.0. I'm sorry, in 1.1. If you roll back 1.3 to 1.0 to basically get back into business to some extent here, well, if your policy has changed in meantime, you have multiple points you need to roll back. You need to roll back all your policy to the right version. And there may be lots of concurrent changes happening in your environments, especially think DC Edge or DMZ firewalls. Those things will get lots of policy changes here. So at this point, we want to be able to roll back the policy to the policy that actually worked with this specific version of the policy. And that's why we actually think that integrating this policy inside the Git environment makes a lot of sense there. Then we discussed that policy impacts builds. If you're in dev, in stage, and in prod, you may have different policies. A policy in dev is okay to have and to be relaxed. A policy in stage should match the policy in prod. But you need to apply the right policy at the right place. So for example, maybe you want to apply the policy in dev but not enforce it, and just use a linter to say, hey, your policy would fail, but here I still built the software. So you can just go and test your software, but fix your policy as well. But in stage, you want to fail the build in the environment if it doesn't work correctly. So all those are things that you can actually define very simply across the environment. And then again, I mean, I can't reiterate that enough, but the developer knows the best his application. I mean, whoever and whatever documentation, there's always this thing, and Cisco IT calls it the tribal knowledge in the environment. And the developer has the best knowledge of this tribal environment. He knows the history. He knows why he did that. He knows where the bodies are buried, to be honest. So we need to be able to capture this knowledge. And that's why closer is better in that context. Hopefully all this makes sense so far, and you can understand. Again, if you have any questions, we'll take them towards the end, but feel free to type them in as we go. Now, why does the integration actually matter in those environments? Well, if you have it integrated, if you're relying on developer, your knowledge sits in the Git repo with the application by the guy or the guys or girls who actually built this application. Nothing can be better documented than there. And you're thinking, I'm thinking overlays as well, obviously, because I mean, Kubernetes is great, but you can have people in Kubernetes. You can I can go to your self-service portal, get 3 VMs, bring up a small Kubernetes cluster, set up an overlay between them, and then you have no idea what's going on there. So if we can have this policy that's integrated in the code again, the overlay doesn't matter for us because policy gets enforced at the host level, for example, in the container environment. Maintain control at this point. With great power comes great responsibility, as Uncle Ben would say. And it is true. You're giving permissions to developers to actually influence policies. And again, errors may or will happen there. Put as many guardrails as you can, but don't make them too tight neither. Because if you're, in the end, everything is an exception, then the whole process is stupid and there. So you want to make it open enough. So for example, only a review is needed if you need internet access. Otherwise, if it's just internal between servers or between a specific set of servers, yeah, it's okay. And you can define all that, and I'll show you what it looks like in a demo. And then finally, troubleshooting is critical, and so is ownership. If the developer owns the policy, he actually knows what he's enforcing across the environment. Giving the right troubleshooting tools to the team responsible for troubleshooting that actually can see what the developer has written, but in their environment, because your network security team may not want to go and look at YAML files. They do want to use their SIEM, they want to use their UI and everything that they have there. So all that's actually critical, that you write your policy as a developer in YAML, but as a security team, you see it in Splunk in the right way that should be seen, for example. And as a network security team, you actually see it in iteration in a way that you can actually read it. And that's really what we want to achieve at this point there. So let's take some examples of policy integration that we can actually run throughout this environment. So the first one, we're going to take a scenario. And the scenario is, I have a workstation. This workstation is running in my data center, and it wants to access a service which is delivered on Kubernetes by a set of pods through an ingress. There's an F5 device in front of this ingress controller as well. Actually, F5 is acting as the ingress in that context. And I want my policy to be as close as possible to the edge. So my policies will go to the host and to the F5. And in my scenario, I want to allow the developer to actually access from the demo pod the dev environment, but not the prod. So that's what we want to enforce. In our environment, I'm using Jenkins as a CI/CD plugin. I'm obviously using Tetration as the policy platform for this environment. And I'm using Tetration as the enforcement point. One just caveat for the people here which are familiar with the Calico, for example, network policy model in the environment, we do use Calico under the hood, but we do not enforce with Calico at all. So Calico is purely a transport network in our example here. And if you're interested, the example pipeline is here. The repo is open. You can go and you can access it, and you can read the content of the files as I go through the examples if you want to. That's up to you. Okay, hopefully all this makes sense. So let's have a look. So for sake of just time, we have a little recorded demo that I'm going to walk you through across what's going on in this environment. First step, let's go and have a quick look at our environment. Let's see what's actually running in this platform. So the first thing we want to do is go and have a look at the Git repo and to get an idea of what's going on there. So I go to my Git repo. That's again the public one that you can access in the environment. You can see that I have files that are set there. There's policy files, deployment files. There's a Jenkins file which has the config across this environment, and that shows you everything there is to know. This is my Jenkins with the Blue Ocean theme, so it's just basic Jenkins here, and you can see that I have my build running in this environment, and that is ready to go. And finally, if I go to iteration, you will see I don't have any policies set for the application I'm going to enforce. The application I'm going to enforce is called myapp-dev. That's what I'm going to enforce. You can see no policy workspaces here. And you can see that in my pod and my application, you can actually see that the connection is allowed. So if I just pause here for a second, when you see green at the top, it means that the access to the database actually works. And this is the response for the database that you see below it. Then it should go red when policy is blocked at this point here. So at the moment, I don't have any policy, so everything is wide open across this environment. Not great in there. So let's see what do we need to do to come and get this policy enforced across the environment in a better way in this world. So we're going to add a policy as a developer. So I'm going to open my YAML file here, and I'm going to go and define my policy. So the way this policy is defined is we're actually using the language from the network policy of Kubernetes. And the reason we made this choice here is because people are just familiar with that. and you don't need to ask them to change their behavior in there. And again, our goal is really to impact the least possible developers, making sure that they can actually get all the data they need, that they can enforce wherever they need without having to relearn something new. And that's really critical here. So if I take network policy objects, the first statement I put at the top is a default deny in the environment. So that's just the syntax you use for default deny in this environment. A few things around that. Obviously, that's a demo environment. In my demo environment, we basically have everything open if there's no policy. There's a pretty low chance that's the case in production. So obviously, your first statement will probably not be a default deny in that case, because the default deny would be implied from your platform at this point. So keep that in mind. You can change whatever you want. So then I have here all my sets of different policies that I can enforce, and we use different policies as we move forward across the demo. But the first one we want to set is a policy that allows us to access from the campus, which is going to be my jump host, which is .71. And I wanted to access a service running in my container environment. And notice here, if you're not familiar with Kubernetes, you may not know the IP address that you're trying to access ahead of time, because all those things are basically provisioned on demand. So if you want to have that to work and you want to have that to be provisioned on demand, you need to be able to rely on tagging, and you need to be allowed to rely on constructs of the environment, like a service name in this case. So here, I'm actually referencing things which are coming from my environment. So what does that mean? It means that me as a developer, I don't need to understand the IP addressing schema. I don't need to understand all those details. I just need to know that I've set my tags in my deployment file, and the tags I've defined is called frontend, and my namespace is called my app-dev. That's all I need to know at this point. And you see, right now I'm using IP addresses for the host name, for the access, but I could actually use tags again across this environment. So let's continue. The goal of this policy I'm setting is basically I'm not going to shoot myself in the foot policy. The reason for that is obviously if I block my access to the front end, well, I might run into some problems. So let's go and make sure we don't shoot ourselves in the foot. That would be a good start. So I've set my policy. Now I'm going to go and push my code to GitHub. And again, I'm in a developer workflow. So notice I'm using consoles. I'm using VS Code. I'm not using any UI at this point. So I'm going to allow only the front end or whatever. Okay, I'm anti-database, sorry, and I don't want any database access. So I just want to access the front end, what you saw before. I don't want to be able to access anything else. And then pushing this code back up to my repo. So I've accelerated a little bit the video on this point, just because I don't think you need to wait for like 2-3 minutes for the policy to run through. But before we go too far, first thing, if you look at the top, you'll notice that this is my code that I'm pushing. And just keep in mind the commit ID you want to remember, B8 at the end. That's the part you actually want to remember across the environment, because we're going to actually reference this a bit farther down the line in there. So I have my policy set at this point, and I'm going to go to Jenkins. And again, you can see the B8 shown here. So again, I've sped it up a bit. So you can see the policy B8 here, and you can see all the stages going through my pipeline in here. So I can see I check out, I pretest, I build, I push, I remove Docker images, I deploy to kube, and I deploy my policies here inside the environment. Again, what did I do as a developer? I wrote a YAML file, and I just pushed my code on Git. That's all I did so far. So all this process is fully automated. And again, feel free to look at Jenkins file to get more details on there. So this is the rendered policy, which is in gibberish, basically. So now if I refresh my page, you can notice I have a new app that is there, which is now the NS app, which is in this environment. So remember again, I told you to remember the B8. We're still at B8 in terms of commit. So what does that mean? It means that, again, as an administrator or network security guy, if I want to go and troubleshoot that, I know exactly which piece of code is pushed here. There's no surprises. I'm working on the short commit B8 at the end. I can go back and reference this. If a developer wants to know, oh, my policy is not there, okay, is my commit already there? Then I have all my policy constructs put there. They're put as UID in this example. Obviously, putting a friendly name would be probably a bit better at this point, but that's just to give you an idea. And you can see my policy being generated inside iteration based on the construct of the developer, which means that, again, me as a developer, I still wrote my YAML file. And then let's imagine Nirali as a network security person, she can actually go and see what's actually enforced in the UI. Same goes for my tags. I'm mapping to front end. I can see front end inside iteration. Again, I don't need knowledge there. You can see good news. Sorry, that went a little bit fast. The good news is that my policy is actually getting blocked across this environment. So we see red everywhere. We want red everywhere. So that's what we're actually looking for at this point. Here you go. And I can see all my denies and so on, which is exactly what we're expecting at this environment. We are actually dialing and timing out as we're trying to access database. I still have access to the UI though, because the UI did refresh. The UI refreshes in the backend, by the way, so just that's why you didn't see me hit refresh there. Okay, so it's actually pretty good. At this point, we have a policy which has been developed by a developer that has been enforced in different environments. So an EDC running F5 and on a container host on the environment. And we don't have any database access at all. Now let's say your developer wants to actually get access to his database and his developer database across the environment. Well, same logic applies. I'm still working on my code here, and I can see things that I've predefined in this example, which I could be typing from scratch in here. So I'm going to come and I'm going to pick up the policy to the dev database, not the prod one. And I'm still going to keep my policy open for the developer, the UI access. One thing to note is just make sure you don't mess up the 3 dashes in YAML, because that just becomes a bit painful. That's what I was actually checking before. So now finally, I actually like the dev database. So let's give access to the dev database. Process is exactly the same. We just go and we push the code in the environment. Code gets rendered, it gets pushed out on the platform, and then magically you will see the access being allowed at this point. So obviously pipeline is still running here. We should be in 51. Build has gone through. I sped it up a bit again because I think you got the idea around that. And you can see here my policies here with the commit T6 now. So we've moved from B8, Bravo 8 to Delta 6. And if I go and I refresh my page, my policy has got updated in this environment and is now enforced with Delta 6 across the environment. And that's pretty valuable for me because, again, I'm still, as the operations team, I can still track everything that's going on there. I can still see that. I could roll back and see the history of the environment in there. I could tweak the policy for troubleshooting. I could see and analyze the policy in there, which is beyond the scope of this discussion today, but you could absolutely do that. And you can see that I picked up my database based on a tag that I've set. And now, here you go. We now have a working database in dev, which gives you that has access, but we're still blocking prod in there. So at this point, we're getting somewhat nicely on track at this point. Again, I still have my developer in total control of his policy, which now brings us to the next step around that. So we have the developer who was able to create his policy to dev in there. Great. That's what he was allowed to do. So no problem so far. But at this point, now what happens if our developer is slightly evil and that he wants to give access to the production database? Because, I mean, again, he has access to policy. And if he has access to policy and he pushes a new policy and this policy is taken through a pipeline, you could end up by having a full access across the environment. So let's have a look at that. Let's try as a developer to go and have access to the production database in there. So again, back to my YAML file. I'm doing everything inside YAML just like a developer would do in this environment here. And I'm going to allow access to prod. Nothing stops you from doing that right at this point. So we're doing it here, going back, pushing my code. As usual, I commit, I push. Evil access, obviously, because evil is bad, and we push. And again, we're going to let all our pipeline run through the environment here. Go back here, let's see. Remember the commit as usual. The commit here, sorry, I went a bit fast on that. Database here, sorry, prod is allowed. Commit is 6 Bravo on this one. And if I go back here, you can see 6 Bravo. You can see all the commits going through this environment here for push. So again, policy goes through in the exact same way across the environment. It's pushed directly to master and so on. So now build is going to run and policy is going to get updated. Let's have a look. 6 Bravo. And let's refresh. And hopefully we should have the same thing. And we again have 6 Bravo in the policy at this environment. So now we're starting to see a bit more in there. And now you can see that the developer did get access to prod 2 in the environment, which is not exactly what we wanted in this environment. Now is the moment that you remember the guardrails part. How do I set guardrails for my developers to not do that basically in this environment? And obviously, I don't want to do like every single workspace and do that manually in the environment. I do want to do that once for the whole platform. So let's have the guardrails in this case, which are going to define that my Kubernetes environment in which this developer is having access to, which is VSX3-Kube, doesn't have access at all to prod. That might be a bit radical. It might not be that in your environment, but that gives you an idea there. So a policy is a hierarchy of policy inside iteration. So you got different levels of workspaces inside the environment. So if I go one step higher in the workspace, so if you see here, I'm now in demo SJC VSX3-Kube, where I was before in VSX3-Kube colon ns equals my app-dev. So if I'm one level higher, I actually get better control and higher precedence, if you want, inside this environment. So that's where the security team would actually enforce policies. And again, security team may or may not care about code. That's really up to you to make this call here. So here I'm going to use the UI and I'm going to add a gray list this time. So now remember, we were in a whitelist model on the application because our default action was deny and we only allow write traffic. Now we're actually creating gray list on this system where we're going to deny traffic coming from my app dev up to the production database, production systems, any production systems for the sake of it. So here I'm going to use the tag, I'm going to create prod, and I'm going to just find out which tags I need to use from here, which is lifecycle equals prod in this case. So I'm now going to go back and create my policy around that with the lifecycle prod. And you can see that the number of inventory item matches updates immediately, and I'm matching 1, which is the case that I just have one database here. So that's kind of expected. filter saved. I need to change with my priority because obviously I want my denied to take precedence as I'm doing gray list. And I'm going to allow basically block, any traffic here. Here we go, deny the my app dev to access any prod system in the environment. So let's have a look at that. I'm going to refresh my policy enforcement and enforce the latest in this environment. And by doing this, I'm actually going to cut off the access to the developer across the environment. So a few things that you have to think about as you're doing that, and that's pretty important. I have not tampered with the developer workspace. I just want to make that crystal clear in there. I chose a higher order environment, a place that actually includes all my applications, and I set a policy there. And this policy is actually going to override the policy developer set, which means that he can't go against this policy. And I'm pretty sure that now you're connecting the dots on why the linter is important in this environment. Because as I'm doing that, the developer may not be aware that something is actually blocking him. So because if I go back to the developer workspace here, I didn't make any changes to the developer workspace. So if he goes back and he sees his policy in his environment, well, everything should be working as per his policy. You can see I still have the exact same policy as I had before. Now, if I had applied my linter in my pipeline and had done it before, what would have happened is that I would actually have been able to fail the build early in the process. And I would tell my developer that, hey, a higher order policy coming from workspace managed by X has actually created this problem. If you want to request an exception, click on this link, for example. And that can bring them to ticketing system or Jira, or whatever you're using to be able to track that. So that would be the workflow that we would be expecting across this environment from a developer standpoint, and how this would actually interact with the rest of the teams. Hopefully that still makes sense for everyone. So let's just go back and see a few more examples here that we can use in this point. First one, the example I showed you here, you remember I use an IP address, the .71 IP address. But actually, you notice that for Kubernetes, I use tags, and you can see the tags again here. System name and service name, and service name there. Well, I could actually allow or reject access based on Active Directory groups in there. So to give you the scenario, let's say that you have a team of developers, and in your environment, developers are part of Active Directory group 1107, like in this example, or whatever name you want. It just happens to be 1107 here. And I just want developers to have access to developers deployed services, because I don't want anyone in my campus to be able to access that. But relying on Active Directory integration will actually allow you to be able to set this very simply in your environment. And you can see the policy is super simple. And again, I'm not asking the developer to learn anything about that. The way you would handle that in your environment would probably just give code snippets that the developer can just copy paste to give access to things, which is basically just like you go on Stack Overflow to get some answers, you go there to get some policy information in there. Now, you could also give access to things like SDTs. So imagine a scenario where you have ICE in your environment, and you have, for example, IoT deployment across the environment. And you want to give access to some specific PLC systems that are authenticated through ICE, and you want to give them access to your application that you're building. Well, that's where you can actually go and rely on maybe a group tag, 17 in this example, which is going to pick up the data from there and be able to go and give you some more details around this environment and force the right level environment based on things coming from ICE. So again, you can see clearly how we still maintain separation between teams in the sense that we don't ask them to go and have a single common kind of view and align on things. I'm taking this data from ICE as ICE provides this to me. I'm taking Active Directory data as it's provided from me. I'm taking network policy as the developer gives it to me. And I'm enforcing my higher level policies as I need to, as a security team. So you can see that the level of flexibility and let's say the separation between teams is still maintained at this point very easily, which also means that it's just faster to get started. All those are very simple integrations that we're looking at between the different endpoints. So we're just not looking at highly complex, you have to go change your data model thing. We didn't instrument any code, and you saw that throughout the examples. I didn't change my code. I just added that dropped in a file called policy dev in there, and I have a second file called policy prod in there. So the impact on the developer is actually very limited. He can also start with very wide policy to get a taste of it. So it is easy to get started at this point. And don't keep that in mind in there. That's why policy is a pretty good place to get started. And then probably a topic for a different discussion, but just to make you aware, the other enforcement point, which actually can get really interesting, is integrating with things like Harbor. So if you're not familiar with Harbor, Harbor is a container repository system. It's open source in there. Harbor has a plugin that's called Claire. Claire is a container scanner in there. So it would, you take the exact same build pipeline I had, and imagine that when you push your policy down to your container registry, well, you're actually going to scan it for known vulnerabilities before. Well, guess what? We can actually also integrate in this process. And by integrating in this process, it allows you to be able to go and say, hey, you know what? This container has a known CV. This CV is XXX across the environment. If I see a container deployed based on an image that has this CV, I'm not going to allow them access to the network. Or again, I'm going to fail the build potentially, or I'll do something to block them or set different policy, be more restrictive across the environment. So that's the level that you can actually go and you can set and integrate really deep down inside the policy pipeline for the application. And that's where you move one step higher and you're moving away from policy now, for example, to vulnerabilities. So hopefully all this made sense. And I kept about 10 minutes for questions and answers at this ones. So before we just go there and you can ask your questions, what if we kind of talk through? Shift left is not so hard. And there, you don't need a big bang to go to shift left. I think that's really the key takeaway I want you to bring back, is that with the right model, if you simplify your deployment, if you simplify your adherence points with the developers and you make their life easier, shifting left is actually pretty simple. It's just a file in a repo. It's very simple to get them started, to get them to understand what needs to be done at this point. Developers will support you. They do like that. I mean, we've talked to lots of developers and they actually like the idea of being in control of their policy in there. It just simplifies their work tremendously across the environment. So we actually do want them to be able to have this access and to see this across the environment. They do like it there. And of course, again, no instrumentation was needed here. Like, I didn't ask you, just like, it's not a performance monitoring system where you have to change your API calls or things like that. This is just a drop-in to simplify your environment. And that's super valuable. Now, you have to consider as well policy as a whole in there. So, like you saw why you should care about policy, there's a simple 3VM diagram and there's a real-life diagram. Enforcement is never 3VMs. It always ends up being the real-life one. So being able to have the guardrails, the multiple enforcement points across the environment allows you to go and fit in to any environment that you want to across there very simply. And obviously, if you want to know more, if you want to understand more around how the policy model works, what needs to be done, you can go to cisco.com/go/titration to get more information. Or if you actually search on YouTube, search for titration, we have a whole set of videos that explain the policy model very simply, and that you can actually go and follow if you're interested in that area and see what are the capabilities there. Hopefully, all this makes sense to you, and you saw some value there, and you could see how to map it in your environment. Now, I'll open it up to questions if you have any. I believe questions have to be asked through the chat, right, Carol?
Yes, people can put questions in the questions window. I don't see any at this time, so maybe we can give people a moment to enter some.
Okay.
In the meantime, I'd like to remind everyone that you can find your CEUs for all completed webcasts by logging into your SANS portal account, navigate to your account dashboard, then click My Webcasts. You can then download your CEU on the right-hand side of the web page. I'm not seeing any. Do you have any closing thoughts you'd like to share?
Look, I think we covered everything.
Remi, we did have a question come in. Sorry about that. I am new to tetration. Can you show again where this flows with Jenkins, etc.?
Yeah, so sorry, just to make sure I understand the question. The question is, where does the Jenkins flow with tetration? How do you interconnect tetration and Jenkins? If I understood the question right.
Yes, he says. He says yes, please.
Oh, awesome. If I could access, I'm sorry for that. Okay. Give me just 1 second. I'm just getting back to that here. Can you see my the video again?
Yes, we can.
Okay, perfect. So if I go back to the Jenkins environment here, let me just pick it up where we had the different stages here. So when you're how does tetration integrate there? So tetration is itself a massive policy engine. So it will handle all the policies for your different actors and stuff like that. The way you integrate with the CI/CD environment is actually that you're going to go and rely on a software. The software, we call it Kupol internally. So it's a piece of software that you use that would pick up the file, the Jenkins file, the policy Jenkins file, sorry, and go and execute it across the environment. The reason we chose to do it like that is if you do a Jenkins plugin, I will lock you into Jenkins. If I give you a model that uses a file that you run and with documented return codes across the environment, I can actually allow you to use any kind of CI/CD pipeline you want across this platform very simply in the environment. So the integration is literally 3 environment variables that you have to set: API key, API secret, and the URL of your tetration cluster. And basically just add that as a step in your Jenkins file. And that's about it. That's all you need to do in there. Does that answer your question?
Yes, it does. So that's all we have for today. Thank you so much, Remi, for your great presentation, and to Cisco Systems for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.